My name is Jay Charney. I'm a research meteorologist with the U.S. Forest Service. And the reason why we've got all of you here today and those who are listening on to the recording is to introduce the concept of an operational application for the Hot, Dry, Windy Index, which we're putting forth as a new fire weather index. And several of you on this list have been involved in discussions about this index in the past, but some of you might be coming to it completely cold. So I wanted to give a brief introduction for sort of the background of the fire weather index, our thoughts behind it, a demonstration of how it works, and then I want to show you a web page that we've put together so that it can be used, we think, effectively in an operational setting, and then talk about kind of what we're looking for out of this whole effort going forward. So first I wanted to acknowledge my co-authors who are not on this recording but may or may not be on any given phone call that happens related to this index in the future. So I'm Jay Charney, or Joseph, and then Alan Schrock is a professor at St. Cloud State University. Brian Potter is Forest Service Research in Seattle, Washington, and Scott Goodrick is Forest Service Research in Athens, Georgia. And we've been working on the concept behind and the papers for and the analysis of the Hot, Dry, and Windy Index over the last couple of years. So the purpose of this presentation is sort of to introduce you to the Hot, Dry, and Windy Index evaluation page. And I want to kind of stress at the start here that this evaluation page is very much a work in progress, and we're kind of looking to see how well this page fits into your operations as IMETs and what we can do to improve it going forward, both from the context of improving the index and improving the page and improving the utility and usefulness of the page going forward. So that's the purpose of this particular presentation. So as an outline, I already touched on some of these things, but the idea is we're going to start with an intro to the basics of how HDW, or the Hot, Dry, and Windy Index, works. Going to look at some examples of case studies we've done in the past. I'm going to walk you through the web page as it currently exists and how one might use it. And then at the end of this, there's a link and an email where you can send questions, or if this is part of a presentation or a phone call or a conference call of some sort, then you can ask questions right away. So we'll see how this goes. So first off, the basics of Hot, Dry, and Windy. Our intent with developing Hot, Dry, and Windy was to kind of try to return to the basic science of how the atmosphere can affect a wildland fire. Part of our motivation here is that the fire weather indices that are out there, be it the Fosberg as an example, and the Haynes Index is certainly the most well-known example, the context of how one would use those indices has always been a little bit fuzzy in a way. Sometimes they're referred to as an awareness index, sometimes they're a fire behavior index, sometimes they're sort of hybrid or a stability index or even a moisture index. It's like they kind of go back and forth over what they're supposed to show you, and it's not always clear what it means when something like the Haynes, for instance, is higher today than it was yesterday. Does that necessarily mean or necessarily tell you what you're going to get on a fire or what's going to happen on a fire? So we're trying to go back to the basic science and come up with an index where if the index gets bigger, it means intuitively that we're going to have worse fire weather, but what we mean by that is fire weather that makes a fire more difficult to manage or control. So intuitively, if you ask just about anyone in the fire business what constitutes bad fire weather, they'll tell you that hot, dry, and windy conditions are what constitutes bad fire weather. And this intuition is supported by the fire literature, and Roger Ottmar's paper from 2014 is a good example, but there's many examples of this concept in the literature. So what we're aiming for here is to develop HDW, the Hot, Dry, Windy Index, into a tool that we hope is simple, understandable, and again, we hope useful going forward. So the basic concepts is that we look at hot, dry, and windy conditions that can affect a fire. So the meteorological variables we're looking at are variables that indicate temperature and moisture and wind speed. And we also want to look at conditions in a layer tied to the surface. And the depth of the layer that we've chosen for sort of our initial rollout here is 500 meters. There's nothing necessarily special or important about that depth, except that it seems like a reasonable depth over which you can consider the meteorological conditions in that layer are likely to affect the fire over the course of a diurnal cycle. But if it turns out that a deeper depth or a more shallow depth makes sense for other sorts of applications or other versions of the index going forward, we're certainly willing to talk about that and consider testing that. The other basic concept of HDW as I'm presenting it here today is that it's meant to provide a daily assessment of whether a fire will be difficult to manage based on meteorological conditions alone. So there's no fuels information, there's nothing in here about topography, it's purely a weather index, and it's meant to provide a daily assessment. So it's not meant to say at 3:30 this afternoon things could get bad. It's meant to say whether today is worse than yesterday and whether we're having a run of days that are getting sort of progressively worse and how today compares to the days around it, and even whether it might get better in the future, whether today is a spike or tomorrow's a spike or the next day might be a spike. So before I go into specifically the formulation, I wanted to show you a few examples of how this formulation of the hot, dry, and windy index works for a selection of historical fires. And for comparison purposes, we're going to show how it works against the Haynes index. So first, we're going to look at the Pagami Creek fire, which happened in Minnesota in 2011. And this is just a trace of the value of the hot, dry, and windy index that we've calculated for that day from August 29th through September 26th. And for those of you who may or may not remember, this was a fire that continued on for 30 or more days during that time period. And there was, September 12th was the day when we had the most spread and the most difficult fire behavior conditions. And the hot, dry, and windy index, as we see here, it shows a substantially larger value on this day than any other day. Now, for right now, let's not pay too much attention to the actual numbers in the y-axes for these plots because I haven't told you how I've calculated them, for one, and also the significance of a number isn't necessarily established in this plot. But at this point, what's interesting to us anyway is that it clearly delineates the day when there was difficult management decisions, let's say, and where fire behavior was more active. Now, to compare this against the Haynes index, here we're looking at a time series of the low, mid, and high Haynes index calculated from the same meteorological data for this entire time period. Oh, and for reference, I didn't mention this, the data that we're using for these time series is the GFS model. So it's the operational GFS analysis or the operational GFS forecast data from this entire day. And so the idea is that the hot, dry, and windy clearly lights up on September 12th, whereas the low, mid, and high Haynes, the mid Haynes goes to a 6 on the 12th, but it also goes to a 6 on the 9th, which was not a particularly bad spread day on this fire. And the other versions of the Haynes, I mean, they're kind of all over the place. There's not a clear spike. And so in the context of trying to look for what days stand out as the worst days on a fire, this we would call a win for HDW, and that it shows that it works pretty well on this day. Now, of course, just showing one fire doesn't mean that HDW is necessarily better or worse than anything else. It just shows that it worked for that one fire. So I'm going to go through a couple of other examples of here, some of which in which it worked well and others in which it didn't necessarily work well, and just to give you a flavor for the different types of variation we see. So here we're looking at the Bastrop fire that happened in Texas in 2011. And this is a case where for the couple of days when the hot, dry, and windy index is high, and September 4th was the day when there was the biggest spread day on this particular fire and most difficult management day, let's say, the Haynes index actually went down compared to values before and after on that particular period. So again, this is another win for hot, dry, and windy, if you will, or at least it's showing that there is a signal on the days when we had the most difficult management decisions to make, let's say, or the difficult to manage fire, or when we had the most extreme fire weather. Also, and we're now looking at the Double Trouble fire. Now, the Double Trouble fire was a single-day fire in New Jersey in 2002. So it was first spotted in the morning of June 2nd, and it was put out by the end of the day. The atmospheric conditions or meteorological conditions reported on the day of the fire were quite extreme. There were very, very dry and very strong winds and also quite warm. So we would kind of expect HDW to light up for that day. It also lights up for the day, May 31st, a couple days before, but since there was no fire on that day, we don't necessarily have a context for whether there were difficult fire conditions. But this is another day or another example where the hot, dry, and windy index appears to highlight days when there was bad fire behavior, somewhat better, certainly better than any of the versions of the Haynes index do. And again, we see on June 2nd, the Haynes index was actually lower for two of the different versions than it was on the days around it. So again, we're getting more evidence here, more suggestions that hot, dry, and windy might be onto something. So now we went back and we looked at the 30 Mile fire. And this is going back to 2001. The 30-mile fire, as many of you know, happened in complex terrain in Washington state. And on this particular day, we see that the, I guess it's the high Haines index, did actually light up compared to the days around it on the day when the fatalities occurred on the 30-mile fire. Whereas hot, dry, and windy showed that it was a high value compared to the entire time series, but certainly not the highest in the time series, and it wasn't an enormous spike. And this kind of highlights the fact that hot, dry, and windy, we're not trying to say this is the perfect index, this is going to light up for all bad days or all potentially bad days for all fires. Our theory about why it didn't particularly light up for this fire is that we are looking at GFS data, and GFS data is half-degree resolution, which means that it's not necessarily going to pick up very local wind conditions. And certainly the report for the fatalities for the 30-mile fire suggests that it occurred in a canyon and might have been very local conditions that contributed to the tragedy. And so this isn't necessarily a place, considering the type of meteorological data that we're using, that we would expect HDW to light up. But the fact that it's in the upper end of the range still suggests that this could have been a watch out day, if you will, even if it wasn't the extreme day that stood out. Now the final fire I'm going to show you here before we get back into a little bit of theory is for the Cedar fire in 2003. This was basically a Santa Ana fire in Southern California, and this is another one where the hot, dry, and windy lit up for high wind conditions and dry conditions, and none of the Haines values particularly showed that this was a special day compared to the days around it. So in a comparison between hot, dry, and windy and the Haines, these analyses for the selection of fires across the country and over the years, let's say, suggest that hot, dry, and windy is peaking on the major spread days or the days of concern better than the Haines index does. And to the extent that that is what we want an index to do, we're suggesting that the hot, dry, and windy could be worth looking at and seeing how it works on other fires. And that's basically the purpose of trying to get this in front of IMETs such as yourself to see if you could look at hot, dry, and windy on fires that you're out on and see if it exhibits similar sorts of behavior. So the analyses that I've been showing so far, these time series analyses, as I said before, the numbers in the y-axis, they're kind of all over the place. For some of them, they were 300, 400, some of them they were 100. And we're not trying to suggest right now, at least, from those time series that a given value has a significance. We're more looking at spikes and saying, how does one day different than another day? So specifically, what do the numbers mean for the HDW you've been looking at so far? The short answer for now is perhaps not much. But since we're scientists, there's always a longer answer, and so I'm going to give you a slightly longer answer than that. So in order to kind of understand a little more about where all these numbers are coming from, let's talk a little bit about what specifically we're calculating here. So HDW is defined as, so hot, dry, and windy, we're multiplying, it's really quite simple, we're multiplying the wind speed times the vapor pressure deficit. The vapor pressure deficit is a measure of both how warm it is and how dry it is. And so when we multiply these two variables together, we get a number that increases when it's hotter, drier, and windier, and decreases when it's less hot, less dry, and less windy. And so the units of this number are kind of hectopascals times meters per second, so not necessarily terribly physically meaningful. But the point is that these numbers would be expected to be higher on days when we would expect more rapid fire spread and more active fire behavior conditions, let's say. And that's what we're trying to highlight here. Now, a real quick diversion here is that one of the questions you might ask is why are we using VPD, vapor pressure deficit, rather than relative humidity? Relative humidity is kind of more intuitive, at least in that we've used it for years and years, and many people have a more intuitive sense of what the relative humidity means. And I don't want to get into too much detail here, but if you wanted to look into this a little bit, there's a plot here of vapor pressure compared to temperature, which basically indicates the evaporative potential of a given air mass. How much water vapor can evaporate into that air mass before it becomes saturated. And what this diagram kind of indicates is that the vapor pressure deficit is a better number for indicating that quantity than relative humidity because it automatically incorporates the effect of temperature. as we all know, a relative humidity of 20% when it's 30 degrees outside, 30 degrees Fahrenheit, compared to a relative humidity of 20% when it's 80 degrees Fahrenheit outside, means completely different things as far as how dry the air really is, what the evaporative potential is of the air, and how a fire might behave, particularly in those sorts of conditions. The vapor pressure deficit is actually a better number for trying to assess that process. And furthermore, when we did some testing of the early versions of hot, dry, and windy, we did use RH and VPD, and it showed that VPD actually gave us better results. So that's why we've kind of hitched our wagon, if you will, to this quantity that isn't as widely used, but that we believe is the better number, and that the data suggest is a better number for assessing when fires might be more difficult to manage. All right. So again, the question on the table at the moment is, do the numbers mean anything? And we're still not absolutely sure, but one thing that we can do is that we can produce climatological values of the numbers of HDW. And we've done just that, and I'm going to show you what the climatological analysis looks like, and then that's also going to feature large in how the web page works, and I'm going to show you some of that going forward as well. So we've produced a climatology using the Climate Forecast Systems Reanalysis product, which is a reanalysis product similar to the NAR that many of you are probably familiar with. You might also be familiar with the CFSR. But the CFSR is basically the North American Regional Reanalysis, but it uses the GFS rather than the NAM. So it uses the GFS model. It's got half-degree grid spacing, and that's what we're using to sort of establish climatological values of hot, dry, and windy at a given location. And then we can compare given values on a day against that climatology, and we can say whether a value is particularly significant or whether it's sort of a garden variety day. And so going back to the cedar fire, here's an example of what this climatology looks like. This was the last example I showed you, the fire in Southern California that was the Santa Ana fire. And then if we look at the climatology values in the back, how we plotted these is as a percentile. So basically numbers in the darkest red are above the 95th percentile of days for the 30-year climatology between 1981 and 2010. So a value of 400 would be expected to happen less than 5% of the time, and so that's definitely very much an outlier on the big spread day. Whereas if you look at the later part of the cycle of this time series and you get values in the greens, those are at or below the 25th percentile, so those are relatively common to get values like that at the location of the cedar fire, which is indicated by the latitude, longitude at the top. So that's kind of the background, where HDW comes from, our initial testing with it, and what we're doing to try to produce a product for you to use. So another point that we want to mention, though, is that HDW, I mean, the idea of just calculating the vapor pressure deficit, which is fairly straightforward to do if you have a temperature and a dew point, or a temperature and a relative humidity, or some sort of temperature and moisture variable, and multiplying that by a wind speed. I mean, you could do that for just about any meteorological observation. It's very, very easy to calculate this number. But how to calculate a number that actually has meaning on a fire, that's actually a little more complex and a complicated question, as all of us probably would agree. And so right now we're focusing on one formulation that is intended to indicate when there is a bad fire day based on weather conditions. And the idea is that one would use this index if it lights up and says Wednesday is going to be a bad fire day. You might go in and look at, okay, what's going to be bad about it? Is it going to be high winds? Is it going to be particularly dry? Why is the index particularly lighting up on those days? And then look at other things like fuel conditions and topography, and that's basically part of the toolkit for helping to determine when there might be a watch out day for weather conditions. But we're suggesting at this point not to try calculating this on your own for a given variable or a given data set that you might have, just because how exactly to interpret it is a little bit uncertain. And we're still working on it, and that's why we're kind of reaching out to the IMET community to see if you guys can help us get some more data for how this thing actually works. So now I'm going to transition to talking about the field evaluation of this implementation of the hot, dry, and windy index. And the point here is that we're focusing on sort of IMET uses. We're not thinking of this as a tool where you would look at a region and say, okay, these are the areas that we have to worry about. We're more thinking of it in the other direction. You're on a fire, you're on a location where you have been for a number of days and plan to be for a number of additional days, and you want to see how the weather conditions have varied for the last few days and how they're expected to vary in the near future based on the forecast models. And this website is designed to indicate that. Now the website itself, we set it up here, and we actually have usernames and passwords set up for all of the IMETs who are part of this call and part of this discussion. And Alan Schrock is the main contact point for information about the web page. So if there's questions about how it's working or if things don't seem to be working, Alan will be the one that you would contact first. But the web link here will take you to the web page, and then there's login info. At this point, it's not publicly accessible. It is behind a password, so only the people on this call and a handful of other select individuals can access it. And we would kind of ask at this point that you not share login information around at this point, but if there's other people that you think would be interested in looking at this, please let us know, and we'll be glad to add them and give them their own passwords. So now I'm going to transition from the PowerPoint to the web page itself and sort of step you through how the web page works. So when you first connect to the web page, you'll get a login screen, and this will vary depending on your type of browser. This is what the Internet Explorer, or the version of Internet Explorer that the Forest Service gives us, looks like. And you enter in your name and password, and you can put in, save the password, and then you can go more directly as you can with any other browser. Then you get to a splash page that looks like this. Now the way that the page is set up is that the first page kind of gives you some brief background information about this. Is the hot, dry, and windy page. It's produced from the CFSR climatology, and we also use the GFS ensemble for the forecast. So we're going to see sort of a spaghetti type diagram going forward for showing what HDW is doing. And the way that the web page works is that on the very first page, there are choices in the pull downs here. And so you have two choices here. You can either look at the climatology, and I'll show what that looks like in a moment, or you can look at the analysis and the forecast. And then what you do is you go in and choose a latitude, longitude for the location that you're interested in looking at. And I'm just going to choose something randomly here. I haven't tested this out at all, but I'm just going to pick a random location. But you would enter in the lat long that is most relevant for the location where you're working at the time, and then you hit go. And up should pop a plot, a time series showing how the HDW, the hot, dry, and windy index that we're calculating with this 500-meter deep layer average, or layer quantity, varied over the last 10 days at that location. So this is basically from the GFS analysis, the 10-day analysis, and then showing how the different members of the GFS ensemble members indicate that the HDW will vary going forward. And what you can see here is that we have a red line indicating the GEFS control, the ensemble control variable of value, and then we have all of the different members, so you can see how much spread there is. And as you would expect with anyone who's worked with ensembles would probably expect this, that the first couple of days, many of the members are in pretty good agreement, and then you get more spread as you go further and further out into the future. But the suggestion from this point, and it's 40.5 minus 119, and I can figure out exactly where that is in a moment, but it feels to me somewhere in the Great Lakes region, so we'll see how close I am. You can see that for the next couple of days, the conditions are not expected to be in the highest percentiles for that particular location. But as we get out to day 4 and day 5, certainly the control and many of the ensemble members are getting well up into the 90th and 95th percentile before it drops down again on the 6th day. So that's the idea for what the product itself would look like. And part of the way that we envision the one might use this is that you can bookmark an individual location. So if you enter in your lat long and figure out the point that is most relevant for where you are and where you plan to be for the next few days, you can bookmark that point, come back to that bookmark the next day, and the page updates every night when the new GEFS ensemble is done. And so you could look at it the next day and see how things are varying and see how things are varying, and basically see if this is giving information that is kind of a useful heads up, and which days are useful, what type of information is useful. And that's basically what we're looking for here. And one of the things, I mean, among the questions, and we have a list of questions that I'll link to in a moment, but one of the questions we have while looking at this particular type of analysis are, do the colors on the background make sense? Do we care about the difference between the 25th and the 50th percentile? Or do we only really care if we're above 75, or only care above 90, or only care above 95? We're not sure exactly when these numbers are going to matter, and how much this might vary region by region and fire by fire. So if there's anything that you all see when you're out on a fire and you're looking at these values that kind of strike you as, well, I'd kind of like to see this too, or I'd like to see either different thresholds or different ranges or different sorts of numbers, then let us know and we'll see what we can do. But right now, this is the product that we put together that seems to us like the most direct way of using the information that we have. So now I'm going to take a step back. I'm going to go back to the splash page, and this still has the same latitude longitude I had there. If you then go down and choose the 30-year climatology, what this shows you is how things, oh, I was way off on my prediction. This is actually in Nevada, because the star appeared there. My longitude sense is out to lunch today, oh well. But anyway, this is the yearly climatology. So this is basically showing what value of HDW as calculated from the CFSR climatology it takes to reach the 95th percentile on any given day of the year. So you can see in December and January and February in the wintertime, at any value above about 50 to 100 is a big outlier. So that would mean it was unusually dry and unusually warm and unusually windy, or perhaps all three at that time period. But as you get into the spring and summer, it takes a much higher value before it becomes unusual, which kind of makes sense. And so this is an example of what the climatology looks like. Now, we don't anticipate that you would necessarily be looking at this climatology on a daily basis, but this is the sort of thing, it's sort of background information for where the colors come from on the plots that you're looking at. And I guess conceivably, if you were in a fire in spring in one year and in July in another year, you might be saying, well, wait a minute, 300 used to be a big HDW, but now it's saying 300 is down in the 50th percentile. What gives? This climatology explains why, because at a different time of year, it takes a much higher value for it to be anomalous. All right, so that's the basics of how the page works. Now, there's a few other things that we've included on the web page. The first, and so I'm going to go down the links here on the left-hand side. The first link is kind of showing how HDW is varying across the country. Now, as I said before I came here, we don't really envision HDW being used at this point as these are the areas that are really lighting up and that we should be worried about sort of thing. But in case we decide to do that sort of thing in the future, this is kind of a first step at figuring that out. And this page should be updating every day and will show basically where we have HDW values that are into the 95th percentile and above, or whatever percentile and above as we going forward. And so this is just showing the max HDW forecast from any of the members on the ensemble. So this is going to be, there are going to be some days where quite a bit of this map is going to be very, very dark red, because sometimes it's pretty easy to get one member of the ensemble to get up into the high percentiles. It's much easier, say, than getting the control simulation. Then in addition to that, we have other things going down the left side. We have a brief introduction and background information that's roughly analogous to what I just presented earlier about how hot, dry, and windy index works. So if you need a refresher or need to remind yourself about where all this comes from, you can come over here. The next link is about the CFSR climatology, and again, this is going through the similar sort of information that I just explained about where the climatology comes from and how that works. And then here's some background information about the GEFS forecast. If the first page you go to is like, wait a minute, I don't remember how all this works, all that information is also available here, and there's also some information, links to the climatology and other bits and pieces of information there. And then finally, here is here's our plea, if you will, is that we've put this together, and we're researchers. None of us are operational forecasters by any stretch of the imagination, but we've put this together with the idea we want to try to make it useful, and we're kind of trying to commit research to operations, if you will, R2O. We're trying to see what's the best way of getting this research tool that we find has some value in the case studies that we've looked at out into the field, and then get feedback to iterate and improve it going into the future. And so the point is that we want to make HDW functional for you, both as an index and as a website. So there's contact information here that I'll link to in a moment for if you want to contact us directly. But the sort of questions we're looking for is, does HDW light up when you expect it to? If you got other products that are saying 3 days from now we're going to have a bad day, and HDW is saying I don't see anything, then that's kind of something we want to know about. And conversely, if it lights up when the other information isn't saying anything, but or the other information isn't particularly highlighting that day, but it does wind up being a bad fire day, that's also or an active fire day, let's say, then that's also something we want to hear about. We want to know when it works and when it fails. And if the more information we get about that, the better chance we have of improving it, testing out other quantities, other versions of HDW, and seeing how we can reduce the failures and hopefully make it work better. We're also interested in knowing, do the plots work for you? Do you have any suggestions for what we should change, what works well and what doesn't? I mentioned before about the percentile color scale. Are there other breakpoints? Are there numbers in there that you just don't think are meaningful or that you find are not meaningful? And if you feel like you would like to see spread between 90 and 100, and that's really what matters, and everything less than 90 is like, we don't really care about that, then we could certainly put together a product like that. We could even put it side by side with the one here so we could compare how they all work. And then finally, as I kind of indicated before, is this a product, or is this something that you think you would be comfortable showing to others? Would you be comfortable talking to fire managers about this and at briefings? Or what do you think it would take before you would be comfortable with that sort of thing? And how can we push this forward, again, to make this as useful as possible for everyone? The other point on this right now is we're making the point, we just have North America in the domain right now, and I can certainly think of one person who might hear this in the not too distant future who might get a little grumpy about that. We are planning on putting an Alaska domain out soon. We don't have it ready right now, but we'll have it ready as soon as we can, and we'll let you all know when that is ready. And then, as I said before, finally, is the website work well enough? Is it fast enough? Is it something you can use in the field compared to the local office? Any other thoughts and ideas about how to make this all better? And then here, finally, at the end is the contact information. Now, as I said at the beginning, I'm Jay Charney. You can drop me an email at any time, and also my phone number is pretty readily accessible on the Forest Service webpage, and people know where to find me. So you could call also if there's something wacky is happening and I don't understand it. Feel free to get in touch with me. If you have specific questions about the website and the interface, Alan Schrock is the one who has had the most to do with putting this together, and the website itself is kind of his baby. But we're all willing to talk to you about how best to go forward with all of this. And then acknowledgments and other info. And one of the people I did want to acknowledge is Jessica McDonald, who is a recent graduate from St. Cloud State University and is about to start as a grad school at Texas Tech. She did an enormous amount of work in a very short amount of time for calculating all the percentiles and making the climatology work. And for a lot of what you actually see on the webpage is very much down to her work. So with that, I will close out here, and I think we're going to stop the recording shortly, and then hopefully there will be time for questions and comments, and we welcome any and all feedback. So thank you very much for listening.